The aim of processing is to separate chemically the image and non-image area of the drawing so that they will receive or reject ink consistently. When processing begins, the image areas consist of passages drawn with greasy lithographic crayon or tuche. Through chemical processing, the fatty acid particles contained in the drawing are liberated, permitting them to combine with the stone itself. Once the grease has been transferred, there is no further need for the drawing materials that contained it. The greasy areas are now ink attractive and form the printing image. Simultaneously, the undrawn or non-image areas are so treated that they will receive water and repel grease. The twofold reaction is brought about through a process called etching, in which a mixture of gum arabic and acid is applied to the stone, desensitizing its surface. The strength and formulation of the etch is determined through consideration of the character of both the lithographic drawing and the stone itself. In lithography, the term etching does not refer to a physical change in the printing surface, as it does in intaglio printing. Although in some circumstances the lithographic etch does produce slight surface changes, these are normally irrelevant to the printing of the image. The purpose of the lithographic etch is to produce a chemical separation rather than a physical demarcation between printing and non-printing areas. Factors that govern etching. Number 1. The grease content of the drawing. Drawings weak in grease content require relatively little acid to liberate their fatty components into the stone. Excessive acid in the etch will destroy weak grease deposits and will attack the grain of the stone, coarsening the image. However, drawings containing heavy grease deposits require proportionally greater amounts of acid to liberate their contents. Number 2. The volume and strength of the etch. Customarily, formulas for etching stones specify a given number of drops of nitric acid per ounce of gum arabic. Number 3. The cumulative result of the etch. Most drawings require a total desensitization that cannot be achieved in a single application. The standard procedure is to etch the work in 2 separate stages. The strength of the first etch should be sufficient to establish the drawing deposits so that they may be replaced with ink. The second etch completes the desensitization by fortifying both image and non-image deposits. Several etches of different strengths may be required for drawings in which the grease content varies greatly over an extended range. Depending on conditions, these etches may be applied in either 2 or 3 stages of etching, so that the cumulative total will not injure the work. Number 4. Hardness of the stone. Hard and dense stones may be etched with relatively strong solutions. Soft stones must be etched with weaker solutions, otherwise their grain will be coarsened or destroyed. Number 5. Atmospheric conditions. The chemical action of etching solution is accelerated by high temperatures and dry atmosphere. It is retarded by low temperatures and humid atmosphere. 6. Reaction time for etched solutions. When the etching solution makes contact with a stone, its chemical reaction will vary in time from about ½ minute to 3 minutes, depending on the strength of the solution, the hardness of the stone, the grease content of the drawing, and the atmospheric conditions. Arranged on the table are materials needed for processing the stone. To the left is the talc and rosin box, etch brushes, mixing bowls, shot glass, nitric acid, cheesecloth, water pan with sponge, and gum arabic. The printer is shown in this stage preparing the etch. First, 1 ounce of gum arabic is measured out in the shot glass. The amount would increase proportionately for larger stones. A dropping bottle is used for the acid. In this case, the bottle is tested in a dish to determine if it is functioning properly. Line up the stopper slot with a slot in the neck of the bottle to increase or decrease the flow rate. The suggested amount of acid is then added to the etch and stirred sufficiently. This is critical in order to have a consistent solution. Next, since the drops of acid are only an initial guide to the strength of the mixed solution, the etch is tried out on the margins of the stone or in an undrawn area of the image. Apply the etch quite copiously. with a brush and notice the reaction. A very weak etch will reveal little or no action on the stone. The reaction time or effervescence of a stronger etch will run from 15 seconds to 1 minute. In this step, the printer is testing inside the image. This method would be used if the stone was lacking margins. Notice in these close-ups the relatively violent reaction of this particular etch. It could be considered a very strong etch of between 15 and 20 drops of nitric acid, and would be used only on the most densely drawn and greasy drawings. The etch is used in this case only for demonstration purposes. The printer is preparing the next step, which consists of dusting the drawing with powders, in this case talc, to help protect the image from the corrosive effects of the etch. In addition, the talc's other function is to ensure that the greasy image does not repel watery solutions of gum and etch. By destroying the resistance, it permits the solution to lie more evenly on the work. A brush is used to delicately distribute the powder. Powdered rosin is usually employed before the talc, especially during the second etch. However, delicate drawings can be damaged by the abrasive character of the rosin. So for this drawing, we will use only the talc. Start with light pressure and proceed to a more firm polishing action. The next step is to apply the etch that has been determined appropriate for the particular drawing. For the image shown, we're going to use a medium etch that should desensitize the majority of the drawing. In addition, the image is also made up of very delicate as well as very greasy areas, stretching the limits of the value range. Thus, in the steps shown, the printer will protect the delicate areas first by brushing in pure gum arabic as a buffer to the slightly corrosive nature of the medium etch that will follow. This gumming out can be allowed to dry slightly while the printer prepares the etch. Since the stone is large, several ounces of gum arabic are used in this case. The etch will again be tested on the margins of the stone and stirred sufficiently. Next, the etch is applied to the margins first and then moved into the drawing. A hand, brush, or sponge can be used for this purpose. By starting in the margins, the strength of the etch is buffered and less likely to damage the image. The slower the manipulation of the etch, the more it reacts. Conversely, the faster manipulation retards the action. While manipulating the etch over the stone, the more delicate areas of the drawing are avoided until last. The etch strength is exhausted in 3 to 5 minutes. However, the continued massaging of the gum is beneficial for good desensitization. If the gum begins to dry, more fresh gum can be added, and the massaging continued. This procedure can continue for up to 30 minutes, keeping the gum in a wet state. At some point after the etch has been distributed, a stronger etch is applied to the greasier parts of the drawing through the wet gum. The stronger etch is blended from the dense areas of the drawing outward so that it isn't too localized, and one doesn't run the risk of burning a halo in the image. A sponge is handy to retard the action of the etch if it seems too strong. In this shot, the printer is smoothing away some of the gum film so it doesn't retard the stronger etch. The fortified etch is then brushed over the greasier area. The printer is looking for a reaction or effervescence, which indicates the etch is penetrating the negative spaces in the drawing. If the etch isn't strong enough to do this, the area will usually close up during the roll-up. A hand or a sponge can be employed to retard the action of the etch. The final step of the first etch is the buffing dry of the wet gum. It is critical that the procedure is done quickly and efficiently. The buffing with the cheesecloth forces the wet gum off the image areas and dries it in the negative ones. This exposes the grease drawing to the solvents that will be used next. If the buffing is not done correctly, streaks of gum will occur over the drawing, preventing efficient removal later. First, a damp sponge is used to remove the excess etch. Then cheesecloths tucked into tight balls are used to buff the gum dry. In the beginning, use long strokes varying the direction. Turn the cheesecloth to a dry section and continue buffing. Small short strokes are finally used, and the result is a surface dry, smooth, and even. The next step is the washout stage. Once the gum is sufficiently dry, dry cloths and lithothene or turpentine are used to remove the drawing materials, which are not needed in the next steps. The gum film or stencil, which has been buffed into the stone, protects the negative or white areas of the stone and is not affected by the solvents. In this shot, one can see the drawing that has been converted into the stone surface and is not affected by the solvent. Next, liquid asphaltum is applied to the solvent-dampened surface using one of the washout rags. A slight amount of solvent will facilitate the distribution. If the coating is too thick, a small amount of lithothene can be added to the surface. Finally, use a rag formed in tight ball and buff the surface dry and streakless. The asphaltum in this case acts as a primer